Azure Data Studio is a lightweight cross-platform data management and development tool with connectivity to popular cloud and on-premise databases. It supports Windows, macOS and Linux with immediate capability to easily connect to Azure SQL and SQL Server. Via extensions, connections to other databases are possible as well, like Postgres, MySQL or even Cosmos DB. You can download it via the link on screen. I've installed it. Let's open it. Alright, here we go. That looks pretty slick, right? This is very much an Azure-oriented tool. In fact, if you haven't got a SQL Server on Azure yet, you can actually deploy it straight from this tool. We've already got one, so let's choose to add a new connection to it. We could now input what we did in the previous demo here as well. So we can use SQL Server authentication credentials or my admin account credentials. But that would be a bit boring, we just did that already. Another approach is to browse for our server and database. So let's choose Browse here, Azure, My Account, and My Marvin subscription. Our SQL Server here is our AppDev SQL Dev WE Travel Inspiration Server. As you can see, the details automatically get filled out. Let's click Connect. And there we go. We are connected to our SQL Server. And from here we can then again access our SQL Server database, write queries against it, manage the tables, users, and so on. My main message here is, well, if you prefer to use SQL Server Object Explorer, use that. If you prefer to use SQL Server Management Studio, use that. And if you want a lightweight Azure-oriented tool, use Azure Data Studio. We've got a database now. We know how to manage it. We know how to connect to it. Now, let's use it from our API. Time to connect to our Azure SQL database from our API. Working with an Azure SQL database is really not that different from working with a regular SQL database hosted on a local server. You can find the connection strings on the overview blade of your database over on Azure. For now, I'm going to choose this one here, the one with SQL Server authentication. This will feel familiar, I assume. It's not the safest option. We will improve on this with a managed identity coming up in a few clips, but for now, this should be okay. So, let me copy this. Don't forget that you still need to input your own password. That's the one you noted down when we created the SQL Server. And also remember, if your local IP is not added yet as a firewall rule, make sure you enable your local IP to access the SQL Server from the server's networking tab. Or if you want, there's a small shortcut there, the Set Server Firewall button here on top of the overview blade of your SQL database will bring you to the same blade. Alright, let's switch to our code base. If you have a look at the service collection extensions file, you see that at line 40, SQL Server is set up to be used together with a Travel Inspiration DB context, which is a typical Entity Framework Core context. This is something I'm sure you'll all be familiar with. We don't need a specific package to access an Azure SQL Server. It's simply the same SQL Server package as you choose to access a local SQL Server. So we simply need to change the connection string. That's defined in App Settings. Let's copy over what I had in my clipboard. And let me not forget to input my password. There we go. Now let's save this. And that should be it. If I now try to run this, the connection should work. Let's give that a try. Our code will still crash, we'll immediately fix that, but we can already check if the connection actually works. If I have a look at the Get Itineraries slice, for example, we see that when getting the itineraries, there's a call into the DB context. So when we trigger that, we should see a call to the Azure SQL database happen. So let me send a request to get the itineraries. And we hit an error. If we inspect this error, it seems that we are connected to our Azure SQL database. So that is good. But apparently, on our database, there is no itineraries table. That kind of makes sense. We've created a database, but we haven't created the tables for our database yet. To create those, we can simply run the migrations. So let's do that. Running the migrations is a matter of running the update database command from Package Manager console. There we go. Let's give this another try. Let's send the request again. And there we go. We're connected to our Azure SQL database and we get back the data we inputted. One more thing. There's a built-in policy in Entity Framework Core which is useful when connecting to Azure. It provides better database resiliency and retry logic. And while it is built in, it's not enabled by default for each connection. But that's easy enough to do. We simply pass through options when we configure the F-Core to use SQL Server. And on those options, we call into Enable Retry on Failure. And that's it. Just to make sure, let's give this one more try. Let's send the request to get the itineraries again. And there we go. And with that, it's time to deploy this. In this section, we'll deploy our API to our app service, and we will ensure that the app service can connect to our SQL Server database. Let's do that first. For that, we need to open the Networking tab at level of our SQL Server. It's still open from the previous demo. One very important thing to remember is that for all of this to work, we need to check this exception below here. Allow Azure services and resources to access this server. Otherwise, our app service won't be allowed to access our SQL Server and thus SQL Server database. Let's save this. All right, now we can deploy. Let's switch back to our Visual Studio. Let's right-click and choose Publish. This isn't new, we did this before, but then we specifically included everything related to the SQL Server databases. This time we want this to be included. There's multiple ways of doing that. One way, which I haven't shown you yet, is by directly editing service-dependencies.json here. I'm just gonna set ignored here to false. This is a dependency of type MS SQL with our connection string as connection ID. So this is the one we need. All right, and let's go to the publish option again. And our SQL Server database is no longer ignored. Let's refresh this. Just to make sure everything is up to date, let's choose to connect. We want to connect to an Azure SQL database. Let's select the correct database here. The connection string name seems okay as well. Let's click Next. Let's choose to save the connection string in Azure App Settings, as that is where we want it to end up for the demo. Let's click Next again, and let's click Finish. And there we go, our application is now connected. By the way, that service connector we're now using would also have ensured that our app service would be allowed to access our SQL database server, if I hadn't just done it already on the portal. I just wanted to show you how to manually do that as well, as not everyone will always use the Publish wizard from Visual Studio. Anyway, let's publish this. That seems to have worked. Now, before I continue, let's have a look at our app service. And let's open the settings. If I look at the connection strings, we indeed now see a Travel Inspiration DB connection string there. Let's have a look at the value. There is currently no username or password in here. I will immediately show you how to get this to work once we start using Managed Identity. But for now, I simply want to use SQL Server Authentication. Like that, we'll be able to see that our app service can access our SQL Server database. So let me just copy over the connection string value from our app settings file. That one does contain SQL Server Authentication credentials, as you remember. And let me paste that in here and save it. All right. Let's restart the app and let's test this by getting the itineraries. So /API/itineraries. And there we go. This works as expected. Now, as mentioned a few times, SQL Server Authentication isn't the safest option. Managed identities are a better approach. So let's learn what that's all about next.